And very good morning to all of you, our respected evaluators, lecturers, and my fellow classmates. Sorry. So today, our second presentation is all about a fake news detection system for Malay news. So our team is also under collaboration with UMOS. So for information, we are being supervised by our industrial supervisor, Mr. Amru Yusri bin Amruddin. Welcome, Mr. Amru. Before we go further, I would like to introduce my team members, including myself. So all of us have come up with the idea of this. And before, I would like to introduce my name first. So my name is Syahmi bin Mokhtar, and we have Faezah Shafiqah, Izzat Jaafar, and Syazani Hussin. So I am supervised by Prof. Madal Dr. Yusmadiyah, Mr. Yusof. Faezah and Izzat supervised by Dr. Jamilah Litidin. And Shazani Hussin is supervised by Prof. Dr. Abdul Azim bin Abdul Ghani. So, next. So, before we go a deep into this fake news detection, we have to look into a broader perspective. So, everyone knows that the overwhelming spread of fake news really mislead readers and bring them into an ultimate confusion. So, it makes them to believe something that is not true to be true. So, this kind of phenomena will lead a bad impact to the society. So what are the problems? So we have found out the problem of lack of fake news detection system for Malay language. So we come up with an idea because current studies utilize foreign news in other languages as data set for proposed AI solution. So we need to make a new approach for a Malaysian context. So as a result, the existing of these AI solutions are unable to capture common keywords in Malaysia. So I need to focus in Malaysia, not in other countries. So therefore, by utilizing this foreign news, as Tata said, may lead to the out of vocabulary error. So we are highlighting the three objectives of this project. So there are three objectives. So the first one is to develop a fake news detection model for Malay news using different techniques in machine learning and deep learning. Second, to evaluate the accuracy of training detection model in detection fake news. And the last one is to design and develop a web application that allows entry of news or URL to verify Malay news. So there are various techniques or various machine learning algorithms that can be used out there available. However, we come across with these four techniques that we found and that show a good capability in creating this fake news detection model. So there are three machine learning algorithms that we use and one deep learning algorithm. So we can see support vector machine, logistic regression, k nearest neighbors, and one deep learning algorithm which is gated recurrent unit, GRU. So all of these are supported by past research paper that we made. We made some tar readings, critical analysis, so we can see all of each approaches have their own capability and good performance in classification tasks. So you can see here that each of the approach have their own, have their own performance that they produce. So we have author, year, input length, data set, features, and also the model performance. All of these are solely based on what past research people have conducted. So in this particular area, so we believe that this model will have the best, or will try to create a good detection model in the future. So we can see each of us we have SPM, LR, GRU, and KN. So we cannot just believe on it, so we have to do it. I'll pass to Faezah to display more explanation about it.
Thank you, Syahmi. So we start to train the model. So the approach that we choose to develop the form model is content-based, which the content-based is actually it works by learn the correlation between the news content and the output. So the content-based is the simplest approach to detect the fake news, but it will become worse if the news is outside of its knowledge. So for example, we detect the news and it will give the output fake or real. So this is example of data collection in our data set, which we have news and label that the data that we scrap is from sebenarnya.my. So this is the statistic for the total number of news and average words in data set, which we can see here. The data for fake news and real news is balanced. And then for the average word in data set, the real news is longer than fake news and all of the news in the data set. So we move to comparative technique between SVM, LR, and Can-N model, which firstly will lematize the news using Sastrawi's Stemi algorithm. Next, the vocabulary will be abstract by top 5,000 frequent word in data set by using word TF-IDF, and then the model will display the output fake and real. So for the CNN GRU, it is a little bit different from the three model just now. It is because firstly we lematize using Sastrawi, same like just now. For the, after that, we embed the word pre-trained on 173 million Wikipedia data set using word 2 byte skipgram. After that, the model will produce the probability distribution, which is fake or real. So after we train all the model using our data set, the accuracy, we can see CNN GRU have the highest accuracy, which the train accuracy is 100. For the test, 99.2, and for the lowest accuracy, Can-N model, we have train accuracy 79.6, 65 for test accuracy. So for the SVM and LR, it performed well also compared to Can-N. So ready for production? So say big no. So why I say big no? Because we intentionally evaluate the model using imbalanced data so that we can see the output of the news that we train. So we use fake news, 9 fake news, and 15 real news. And this is an example of the production data that we label news and label. We have fake and real. And then this is a score from the data that we trained just now. That the score is highest score is just only 0.48, which linear regression. But for the others model is below than linear regression. It is because we lack of predictive power on production data. So what's next?
So thank you, Faezah. So here where stance detection appears to solve the limitation of the content base. So what is stance-based approach? Stance-based approach is different from content-based approach because it learns on how the similarity between the news and the trusted source influence the output. So for stance-based approach, it has 4 states of output, which is agree, disagree, discuss, and unrelated. So the benefit of using this kind of approach is that it learns the similarity and the content, but it requires additional data. So this is the data representation in our database for stance-based approach. So we have news, we have trusted source, and we have label. So this kind of data is scraped from sebenarnya.my. So the total number of news that we have in our data set, which is 1000, we have 500 with label agree, another 500 label disagree. So the data is balanced here. Then let's look on the simple architectural representation on how machine learning algorithm detect fake news using stance-based approach. So here we have news and trusted source. So these two will undergo lemmatization using Shafiqah stemming algorithm, and then it will be vectorized using word TF IDF based on vocabulary that have been constructed by extracting top 5,000 most frequent words in the dataset. And then we'll concatenate the news vector and the trusted source vector and train our machine learning algorithm, which is SVM, LR, KNN. And then as the output, it will provide a probability distribution in order to classify the news, either it is fake or real. So here is architectural representation on how deep learning algorithm detect fake news using stance-based approach. So here we have news and trusted source. It will undergo lemmatization using Shafiqah stemming algorithm, and then it will be vectorized using words embedding with dimension of 300, pre-trained on 173 million Wikipedia dataset using word-to-vec skipgram. And then it goes to CNN, it goes to GRU, and we will concatenate it, and as for the output, it will provide the probability distribution, either the news is fake or real. So, for model evaluation, we have made accuracy comparison for each four model, which is for SVM, LR, CNN, GRU, and KNN. So here it shows that LR gives highest performance in terms of accuracy. Unfortunately, KNN show the lowest performance in terms of accuracy. However, if you look at SVM and CNN GRU, it also gives a remarkable performance in terms of accuracy. So let's evaluate our stance-based model using our production data. So based on production data, it shows that F1 score is low, but LR produced the highest F1 score, which is 0.583, and again KNN give a lowest one, which is 0.416. So this is because it's lack of predictive power on the production data itself. So let's recap on both content-based and stance-based approach on our production data. So here you can see that stance-based approach outperform content-based approach in order for model performance F1 score on production data. So we can say that stance-based is better in terms of performance compared to content-based approach on production data.
Okay, thank you, Izzat. After performing some analysis and experiment, we conclude that we are going to use the stance-based detection as our final classification model for fake news detection. So this final classification will be embedded into the web service and will be deployed into the Heroku platform together with the system logic. So this system logic responsible to pre-process, to stemming, and also detect the news. So the flow of the system is quite simple and straightforward. User may submit any kind of Malay news or URL of a news site, and then the system will pre-process and vectorize the news. Next, detect whether the news is fake or real, and then display the detection result. So to provide with a clear view, so let's do some demo. So this is the example of a real news. So user just need to enter any kind of news and then click on Semak Berita. Okay, during the loading, the system not only perform the fake news detection, but also perform the entity recognition, sentiment analysis, and also the topic modeling to provide the user with the detailed analysis on the news. So this work together, be patient. Okay, here is the result. So as you can see, the news inputted by user will be displayed together with the entity recognition. So the different color indicate different entity. So if you hover on the top of the text, it will display what kind of entity that would belong to. So for example, Kuala Lumpur, the entity is the location, and for Parti Keadilan Rakyat, it's an organization and correct, and for Datuk Seri Anwar Ibrahim, for example, it's individual. So correct, the entity recognition really perform well. So for the detection result for fake news, we intentionally display 4 models, which is to provide which model detect correctly. So SVM and CNN GRU detect the news correctly, but the LR and DNN wrong. Besides the detection result, we also display the subjectivity, whether that news is actually a subjective opinion, which cannot be evaluated, or a news. And also the sentiment, which is positive, the topic related to Anwar Ibrahim, parliament and politics, and also the tokoh, which is the individual that related to the topic of the news. So besides news, user may also enter URL. Okay, same like news, just type any kind of URL and then click same up. So the result will be same. So the result will be same like previous. So here is the result about Institute Raja, a different data from previous but no Izzat. So this is a different data. So just go through and then the result will be discussed. Okay, back go to the slide. Okay. As for the contribution, we found that the hybrid deep learning algorithm using the CNN and GRU really perform well for the content-based detection, while the logistic regression approach outperform others instance-based detection. While beside these two kind of techniques, SVM also displayed a remarkable performance on stance and also contents, but unfortunately, we found that CNN yield a poor performance among all 4 methods. So as the conclusion, the limitation of our system is that the data set. So the data set we use is insufficient. So content-based we use 4,000 and stance-based 1,000. It might describe why these 4 models underperform and not perform well in the production data. So for the feature improvement, we are suggest to use a semantic features or increase the data size, of course. So that's all from us. Thank you very much.
So thank you to group number 2. We are so
So the 300 is our FYP dimension, okay? So the 100 dimension is the word token for each word. For the news, we limited the number of words to be 100 because several studies that conducted for the CNN found that if the length for the input is a variable, so it will produce error for at the CNN layer. We call it global map pooling layer for the variable length of input. That's why we we paired the shorter news and truncated the longer news to fix to hundreds words only. For each word, we produce 300 dimensionality of word advantage.
Excuse me. Well done. Is this the part of the work that has been implemented in Indonesia for now? No. Is your part of the work has been implemented now in Malaysia? Because you mentioned just now sebenarnya. Just now, right? Sebenarnya to check the validation of the fake or the true news or the right news.
For your information, Doctor, so sebenarnya Norma is actually a government portal that displays fake news. So from that, the Malaysians actually is encouraged to check the news first in the web portal. So we scrape the data from that because it's authorized by the MCMC itself. So the data is, we believe that data is correct because it just displayed or just deployed by MCMC, Malaysian Commissioner and Multimedia. So yeah.
But the website is manually updated, which means the content is manually updated by MCMC. So our approach is different because we deploy AI.
Thank you.
If there is no more,